Now, researchers at the University of Toronto, through innovative quantum experiments, say they have demonstrated that negative time isn't just a theoretical idea. It exists in a tangible physical sense, deserving closer scrutiny. The atoms sometimes absorb photons and later emit them, leaving the atoms in an excited state for a short period. Measuring this period was tricky, and to many it sounded like it might flirt with impossibilities. Steinberg and graduate student Daniela Angulo focused on the short time atoms remain excited. By collecting data on how atoms emit absorbed light, they uncovered intervals that appeared less than zero. It is widely known among scientists that light sometimes appears to exit a material before it has even entered. This odd, negative time phenomenon was long seen as an illusion caused by the way waves become distorted by matter. Over time, many considered it a harmless quirk of physics, dismissed without much further investigation. Now, fresh experiments suggest that this behavior might carry deeper implications related to negative time. Researchers recently posted findings on the preprint server Arcshift, drawing global interest and some reservations about what it all means. Negative time is no longer theoretical. Ephraim Steinberg, a University of Toronto professor in experimental quantum physics, has seen how people can misunderstand discussions about negative time. They follow probability rules that let them appear in multiple states at once, prompting a range of possible outcomes. This fuzziness underpins the notion that events do not always fit into a neat timeline. In standard settings, photons pass through materials in ways consistent with well-established physics. But in the group's experiments, certain measurements produce results that slip into territory most would never predict. These findings spark curiosity about how quantum mechanics can present effects that appear at odds with common sense. The concept has captured the attention of many, including German theoretical physicist Sabine Hossenfelder, who remains unimpressed. The negative time in this experiment has nothing to do with the passage of time. It's just a way to describe how photons travel through a medium and how their phases shift, she said in a YouTube video with more than 250,000 views. Some observers suspect the term negative time is too dramatic and misrepresents the study's scope. Others argue that a fresh approach could encourage deeper conversations about how quantum processes unfold.